All right. So this is session 6, and we're going to be talking about higher ordered functions and what that means in code. And so y'all will have a way to relate. We're gonna be doing a lot more like interaction with functions today. Just making some and passing them around. Yeah. And hopefully today we'll pick a challenge that that doesn't have so many steps like yesterday's challenge. Yesterday's challenge was pretty long to walk through. I don't know how many people this time I was ready for that record button this time. I am prepared today. So today is going to be higher order functions, and sometimes some languages you'll go to, actually a lot of languages you'll go to, you'll hear them talk about higher order functions, or functions being first class citizens. And we're pretty much going to talk about this and what that means for your code, and like the abilities that gives you. It shouldn't be too long of a lecture, so hopefully it'll be more of me demonstrating some things than me talking, because there's only a few slides to go through. It looks like we have about 10 people. Well, there'll be a recording, so anyone missing it can catch up. All right. So higher order functions that operate on other functions by either taking them as arguments or by returning them are called higher order functions. And in this example, you can see if you look at each one and what the variable name, the like parameter names kind of are implying. This first function, if we look at it, it's a function, its name is add, and it takes 2 parameters. So I'm just breaking this function down step by step. num1, num2, I'm assuming these variable names are trying to be consistent with what the data type might be. So these are probably numbers, is a safe assumption, at least from reading it. They're just doing a very simple operation, right? They're doing addition. Because of the left side and the right side of the plus sign are numbers, it's going to do math operations with addition. And then it's going to return the result of that operation. And then we have multiply, which it looks very similar, right? Like it takes 2 parameters, they're both numbers, and it's doing a different operation. They look very similar. And then we have this third one that's just more generically named, called arithmetic. And arithmetic pretty much means any kind of operation itself, right? It doesn't just mean it's sum or product or like adding or multiplication. It means like you're trying to do math, basically. It's a generic term, so they've generically named it, but they also added a third parameter here called calc. So number 1 and number 2, we know that they're going to be number types by their names, but calc doesn't really imply what that might be. And this whole idea of higher order functions or functions being first class citizens, it really means I can treat a function as if it was any other piece of data type that I'm working with. Like I can do all of the same things with a function like I can do with other data types. Like I can pass a number around. I can pass it as an argument to a function. If we look at the first line of the code, it kind of reveals that calc isn't a number and it's not a string, really. It looks like we're calling a function, but we never defined calc as a function. And that's because somewhere else called arithmetic and then passed like one of these names into it. Like I could have passed, we'll show you in the next slide, and when I do examples of this, we're going to physically call a function, and from the calling side, this is we're looking at the definition side of the function, where we have defined the name and the body of it. from the side on which you call it, I could pass add without calling it, as if it's like a data type, right? Like it's like it's an object of a thing I can pass around. Function is a value, it's stored somewhere. So I can pass it as, it's basically getting reassigned a new name within the scope of this function. And we talked about scope in the last session yesterday. We talked about scope. Calc is going to exist inside this function and the scope of this function, but it's really going to point out whatever function name we passed it. So calc, so if I was to call arithmetic and I had passed it add in this spot, calc is now basically the equivalent of this function. So I can call, so when I call calc like this, it's basically going to run adds logic. I'm basically did like a reassignment of the name within the scope of this function. And this helps you like create more flexible functions. And this isn't all you can do, but this is one of the things you can do. You can pass a function itself as an entirety, like a reference to some logic that you want to run by the function's name. And that's what happened here is calc became whatever function we passed it. I still have to pass the same numbers. Like I still have to match these parameters with the arguments when I call calc. Like these parameters have to be in alignment for this call to happen. But this makes my arithmetic more flexible. Now I can say, here's a number, here's what operation I want you to perform. And then now calc could be add, it could be multiply. I could create more functions like divide or perform like some kind of exponential, like take number 1 to number 2's the power of number 2. Or I can make all kinds of arithmetic operations now. But, oh, I didn't know there was, I guess I should have clicked once. So there is a calling, right? So this is what it would look like if we called it. And I call like calling arithmetic and I passed it like the literal number 2 and a 3. So 2 would go in as number 1. And the second position, number 3, would go into the second position of number 2. Oh, sorry, I'm pointing at the wrong one. I should be pointing at this function down here. So number 1 is 2. Number 2 becomes this literal value of 3. But then calc is going to be add. It's it's almost as if I wrote add right here in calc spot and referred to this function, but that's not what happened. I passed it in because functions are first class citizens. I can pass them as an argument. Like right here, I'm passing the name or the identifier reference to this function. So, and that lets me like, this function's like, okay, I've received a function object here. I'm gonna rename it. We're not gonna call it add from in here. We're gonna call it calc, but it's still gonna point at this function right here. So I can still call it as if it was add. And then it will just do this operation. But this also lets me, like this, I can swap this out now with anything I want. Anything that accepts 2 parameters and does a different operation, I could put in place of here. So I could have wrote multiply. So now arithmetic can do adding, and on the next line I could do the same numbers but then pass multiply, and it makes this arithmetic function a little more flexible with what it can perform. Yeah, so and then calc is this line is almost the equivalent, or it's basically the equivalent of me calling add without making my code dependent on add having to be there. Like the name of add. It didn't have to be called add. It could literally be another function name. I could swap this out as long as I update what I've passed in, it will still perform the same operation. Yeah, so why would we want to do this? And we can reduce the complexity of all of our functions. We can have functions call other functions. So every function can perform one job. And that's kind of like the mindset you want to be in anytime you're creating functions. The goal of a function is normally to have that function perform its job, like perform one specific task and perform that one task like well, like it can do that one thing. And this lets you create a lot of really small focused tasks that you can perform. And then you can like modularly combine them together to perform a much bigger task. So you're breaking everything down into small tasks and then piecing the pieces you need together to perform a more complex task uh, in smaller pieces within your code. And if you write functions this way, in a very small, confined, focused way, whenever you get to unit testing and things like that, um, if you become a web developer, you're going to learn about unit testing, like how to test my code to make sure like it's doing all of the things I want it to do, and making sure it accounts for things that I didn't account for when I wrote it. You're going to get into unit testing, and if you write really focused functions that perform one simple task, they accept some parameters like num1, num2, and this resulting return value changes depending on the inputs. Like the output depends on the incoming inputs, and it's written in a consistent way. You can test it, and you'll have a really easy time writing tests for all of these functions. But once your function starts doing more than one thing, like when it starts becoming less of one focused task, it's going to be much harder to test it later. Like then you have to make all kinds of considerations, especially if you have like this cascading if, elif, 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 and you're just going elif all the way down, and then you eventually get to an else, and like you're doing all these conditions, and your function's like hundreds of lines long, and it's doing more than one thing instead of one focused thing. You'll run into issues with trying to test that one function. It becomes very complex to it becomes much more complex to test something like that. But as a developer, you'll always be trying to reduce complexity of things so that it's easy to test and easy to swap things out for maintainability of your code. But that comes with time and practice. So don't get caught up too much on writing perfect code right now. So that's it for slides. Like I said, it was short. So we're going to actually practice with this a little bit just so you can see what happens in the console when we're trying to do things like this, not just from slides. So I'm going to open up REPL, and we'll write. We can write someone similar to this just because they're easy to reference from the slides, and play with some of these ideas of what we can do in here. So, well, actually, let me step back, and we'll talk about the higher order function first class citizens part, and show you what that means, and then we'll get into like writing a function does something that the slides show. So functions being first class citizens, it means a few things. It means we should be able to pass them around like a variable. We can pass them as an argument into another function. And it even means that a function can return like a call to another function, or it can actually return a function. Like you can build a function inside of a function and return that new function. So it's like function inception, but it gives you a lot of flexibility and power what you can do. So first, let's look at like just passing it as an argument to a function. So I'm going to create, which syntax do I want to use here? I keep writing it this way, even though I say it's probably preferred to use the ES6 syntax. Maybe I'll mix and match in here today. Just write the different ways you can write a function. What can we do here? We can say, I'll just use the example just so you have a reference. I don't want to invent something that wasn't in the slide. So arithmetic, I'm going to call this one calculate because I like that word better than writing out arithmetic. So I'm going to call one called calculate. And it's going to take the same number of arguments. So we'll do num1, num2. And then I'm not going to call this one calc because I don't want to repeat the naming convention. Like I want you to be able to follow this too. So I'm going to name this one like something not as good, but more obvious. I'm going to call it our function. It's not a specific function. It's really just any function. I can pass a function here. And I just want to show, well, for the moment, I'm just going to console.log our function and then leave it at that. So I'm going to call my own function. I'm going to pass it 1 and 2. We're not performing. These are just there for something we'll do in a few steps. But I really want you to see what is happening here. So I'm going to create a second. I don't have a second function at the moment, so let me like make one. We did like a say hello function in one of the previous ones. So this this function, it's not even going to return anything either. It will literally just it's just going to console.log a hi there. And I kind of want you to see like what happens here. So this is me calling calculate, right? I'm calling or invoking calculate function with 3 arguments. So I'm passing 3 arguments, 1, 2, and then a function. I'm trying to map what my parameter positions are here. So that 1 goes there, 2 goes there, and then I'm going to pass say hello, but I'm not going to call it. I'm just going to pass it. I'm going to pass like the name reference to that function. And so this one is going to run, like this call is going to run this function's code, which is only this 1 line. And it prints out in this blue color, say hello. That's basically the function's name that I passed in. So it has brackets around it, which makes it kind of look like it's some kind of an array, but this is also JavaScript's. It's not only a way that JavaScript represents an array of things, but it also uses these brackets to represent objects, because an array is technically also an object in JavaScript. So these brackets technically mean that it's an object, but it's a function object.
Chris, how come hi there didn't show up?
Yeah. So like I said, I'm not going to call it, right? If I call a function, I need the parentheses to like invoke. That's when yeah, the parentheses are literally you saying, I want you to run your code. But if I take the parentheses off of it, I'm just referring to the name. I'm saying, hey, I'm just referring to, but I'm not telling you to run. I'm just like referring to where you're at in memory, basically, by your name. So I'm kind of passing it into this function, right? And I don't call it say hello right here when I passed it in. Like this was its name and its reference that I passed here. But when this function receives this 3rd argument, it's like, hey, I'm going to reassign this to this new name. It's basically like taking that incoming say hello and it's doing like, it's doing like an assignment, right? That's what these parameters do. It's basically like setting scoped variables to this function. That incoming, this isn't a thing, but that incoming say hello function reference is getting assigned to this new name. So our function right now, at least in terms of line 13, our function is the equivalent of me saying say hello. So if I was to put parentheses and call our function, it is the equivalent of me putting parentheses on the end of say hello. It's just like if I'm calling that function, because they're sharing the same name, or basically I reassigned in the scope of this function, I reassigned its name. I didn't reassign its name outside of the function. It still remains the same. But let's look at that. Like let me leave this one. Let me leave this one here, and I'm going to actually call it. And because this function console.logs, I'm not going to console.log a console.log. I'm just going to call it. I'm going to call this name right here. So our function, and I'm going to call it because, like I said, our function is basically say hello's name. So I can treat it still like as if it's a function. So if I do that, it says hi there. But you know, like it doesn't look like I ever called it, right? Technically, I passed it in here and this became its new name. So it's as if this line right here is as if I did that, right? If I clear that. Oh, did that run fast? That was pretty quick. I clicked it way too many times. Come on, you can catch up. All right, we got there. So it says it's basically like this, right? But if I, then you ask the question like why do this? Why can't I just do this? But it create doing this right here actually kind of makes calculate depends on say hello existing. Like if I do this, if I ever want to change the behavior that happens in here, now I have to physically come in here. It's not as flexible. It loses flexibility, right? I really just want to call this function, but what if I have more functions? Say, I don't know. I'm just kind of making stuff up at this point, but like I have two different functions that do two different things. One says hi there, one says hello world. These are just contrived examples. You might actually do something much more important here, but if I'm trying to update my calculate method, maybe I want to call, if I want to choose between these two things, right? Like, I might be going a little far with the contrived example here, but like maybe I need to conditionally select to run one of these functions, right? Like this isn't Python. If num1 plus num2 is equal to 3, maybe I want to say that. Otherwise, I want to run the say hello world or something like that. I don't know. Just like now I have created two dependencies on calculate. Like calculate needs to know these names. They have to exist for it to even run, or calculate will fail. And also, if I ever change these function names, I have to also come find, like I could have 1,000 lines of code in here, right? Now I'm gonna have to go find and fix any references. If I was to like update this name or alter it in any way, now I have to go find every reference and update it. But if I just make it a parameter and I pass in the function that I want here, I don't have to rely on knowing what those names are. I don't have to care about it. I can literally just say, this is what I've called it in the scope of this function. Let me just refer to it as the function refers to it. Like, let me just call it by whatever the function assigned to it. And I can also, it also lets me get rid of this if or else if, because now I can pass two numbers and say, here is what I want you to call. I don't want you to, I can do my conditional logic not in here, basically. I can do it at a different point in time. And then this one can just concentrate on performing the call and returning the value. But this was a little bit farther than I want to go with this example, but you can see how like it helps you, it's trying to help you keep a more like a reusable and more flexible function to work with. Because if I do it this way, I don't have to rely on knowing, right? I can pass, the only spot I would ever have to update if a name changed is this one, if I'm using the R function. So if I'm not doing this, if instead I just wanted to do our function, now I can run a say. Now it makes it really easy, right? Like if I pass a 1 and a 2, I can pick what I want to go here specifically. So it says hi there. I don't want to say hi there. For this line could be part of a more elaborate function somewhere else that you're just calling to. You've already done some conditional logic, and maybe your conditional logic, the other side of it, it needs to do the say hello world instead. So now I can just pass it the reference to the function, like, hey, I'm going to pass you a function that you're eventually going to call. And that's what this is doing. But that's not the only thing I have to do, right? Like I can, or only thing I can do. I can pass in these numbers alongside this function, and then also, if I wanted to, I could forward them in to this same function that I passed in, and return. Well, I can't return at the moment because neither of these functions return. One of these function is going to get assigned to this function, so I probably want to return a value instead, right? Hello world. And this one can return its, whatever its value is. And again, these are contrived examples. You probably wouldn't do this in the real world. We would probably use, because this is calculate, we probably use math numbers, which we can change it to in a second. But you can see now, like I can get my result from that. I can say, all right, go perform your work. And then I can take this result if I want to and say, all right, get my eventual result, and I want to add something extra onto it, right? So since we're returning, data types are important, we're returning strings from here. Result will be a string. I can do string concatenation. So I got my result, and then I just concatenated an extra result on the end of it. And line 18 should print out when I run this. So now it says hello world, and then calculate added its portion on top of it. But now I can swap out what I'm passing in and still get the same effect. So it just lets you, and now I can like create any function, any more functions I want. Right? I'm not picking good names here, but it's fine. But it still returns a string, so I can put on like that function I just wrote in here, and it will just say Chris calculate added this, right? So it lets you get a little more flexible with your code, and that's the purpose of it. And it's very useful in the language feature to have, because you're going to find out as you write your own code, if you don't have this in mind, or if you're not keeping this in mind when you're writing code, you're going to go the only way that looks like you can go, and you're going to write like extremely long functions, right? They're going to do a lot of checks, a lot of different actions that it's going to perform, and the more things that your function ends up doing as a whole, like when I call calculate, if it did a lot of checks and a lot of things that it probably shouldn't do, that some other function could have done, it's going to make your code really hard to maintain. But this is basically to like get you to associate, when you hear this word, higher order functions, or functions are first class citizens. The fact that I can do this lets me write some, it lets me invent some really clever solutions for things. So because I can just, I can pass in multiple functions. I can have my function call, I can have another function call and run the passed in function at any point in time. But yeah, we could do like a proper like math function now. So like we could write our own. Let me do ES6 syntax for this one. No, not let. Let's do const some numbers, or yeah, I guess we'll do that. And let's make it match the parameter listing for the moment. So it's going to accept 2 parameters. And again, this is the other way to write a function. It's the newer way to write a function. The one on line 8 right here is the old way. So it's literally going to just take these 2 numbers, add them together. And I'm going to, this will still work. This line right here will still work, but I don't want this anymore. So I'm basically using this function to call the function that was passed in. I'm saying, hey, you're going to receive a function. It's your job to call that function, get the result, like forward. You're going to forward on these numbers into that function, and then you're kind of like a proxy, right? Like you're going to have it go perform the task, and then it's going to give you a result, and you're going to give me back that result. And that's what this line is. So calculate is the function I'm calling, and the thing I want to perform in my calculate is I want to sum the numbers, or basically do addition with some numbers. And if I run it, it gives me 3. So it took 1 and 2. It's taking in 1 and 2, right? So we're mapping these two numbers to these two numbers. It took my function that I'm passing in, and the only thing, when we call some numbers, the only thing it's going to do is it's going to take whatever it received for numbers, even though I named them the same thing. It's going to take these two numbers, add them together, and give it back. So this line is going to basically, it's basically the equivalent of us doing some numbers. We're forwarding in the arguments that calculate received, right? Calculate holds these numbers as these references. So we're passing them into some numbers. Some numbers, because of function scoping, we can keep these. These don't have to be the same name. Here, let me do that just so it's clear that you don't have to make these names match, right? I could have called this argument 1, argument 2, like this. But whatever calculate had stored for values in these numbers, they're going to get, this function is going to reassign those values. The same thing that this R function thing is doing to some numbers. They're just reassigning they're just declaring these variables inside of the scope of only this function. So it will only exist for a temporary amount of time. But anyway, back to line 10. This line right here is basically as if I did let result equal some numbers, because that's what we passed in right here, and I'm forwarding on the other two arguments into it. So this call, so this was our initial call, and the job of this function is to perform another call on the function we passed in. So some numbers is going to run, it's going to do addition, it's going to give us back our result into this result variable, and then it's going to return that result back. So that's everything that's basically happening on this line right now. Like calculate's only job is to accept some numbers and a function and then make it happen, right? Like its job is to call that function and pass in the arguments. So we could actually modify this even more if we wanted. Like I could make this, what if I said that this is numbers? Maybe I'll say ARR for like short for array. Maybe a lot of numbers, right? I'm just thinking of a way to like go do a lot more numbers at one time. So instead of accepting two of these numbers at one time, we'll just call this one nums, just so I can keep these two parameters named different. But my assumption now, as I'm rewriting this, I am choosing that nums is going to be equal to some kind of array that has like none, like no numbers, or a lot of numbers. I'm actually going to do like basically part of a code challenge right now. I don't know if it's a code challenge any of you have, but it's a code challenge it's a beginner code challenge. If you want to get the total, we'll do it the long way. We're going to start from 0. I'm going to loop over this array of numbers that is going to like come into this when it's called. Basically the number I'm going to send in right here. So let me do this so it's obvious, right? I'm sending in an array of just 2 for the moment, just to keep it simple. But we're going to make that a little bit bigger and just see what happens. So I want to total up these numbers. The job of this function is to like iterate over an array of numbers and determine like the total, right? So we'll do the or regular style C for loop, which looks like this. I less than nums is an array. It has a dot length attribute or a property to it. So I'm going to iterate over this nums array, right? Like that. So this is first iteration is going to be 1. And actually, let me put this on the line above so I can do both of them. We only have 2 iterations going to happen for the example that I'm doing right now because I only put 2 items in there, right? This array that I'm about to forward, I have to fix no, I don't have to fix that. Okay, so I'm going to iterate 2 times, right? That makes sense. I'm going to iterate over this array or loop over this array, and there's only 2 items. The first iteration, nums is going to be nums I will be that, and then the second iteration nums I will be that. So if everyone's tracking them with that so far, I want to just increment my total by whatever these numbers are each time. So I can say total is equal to the current total plus our current number. So total is equal to our current total. So current, maybe I should have named this current total. This is our current total. It starts at 0. And then this is just again, just some review. This line, the start of this line, this is reassigning, which means this total is referring to the previous, our previously assigned, whatever this value currently has, which this line is updating every single time we iterate. If everyone is tracking with that, we've done this before, so hopefully it's not new. Total is equal to our current total plus whatever nums I is on currently, right? So we're incrementing that total, and at the end of it, total should have iterated over every number and just kept adding every single number. So I'm going to get rid of this line. And before I run calculate, I'm going to run this without calculate just to make sure it works. So let me get rid of that and let me call it myself. So some numbers, and I have to pass it an array because that's what I decided on. And I'm going to pass it 1 and 2. And I expect that I should get a 3 out of this if everything is written correctly. Actually, let me make it 1 and 3 so it's different than what we've seen from calculate. So 1 plus 3 is 4. If I just pass a 1 item array in, it should still just be 1. And then if I pass nothing in there, our loop has nothing to loop over, but it should still, it won't loop over nums because there's nothing in it, but total was still set to 0. So I expect that a 0 would come out of this, and I get a 0. And if I don't pass it at all, I get cannot read dot length. So basically, I didn't pass an argument here, which means that nums was undefined. I didn't pass. So keep your errors in mind. I didn't pass anything, so I'm getting an error. I can't do this, basically. That's what it thinks it's trying to do. So just keep awareness on passing in your array. So we know that the sum function works. Now I want, this is good at I can pass any number of arguments now, right? Let me just do that real quick. So some numbers I can pass 1, 100, 2000, 333. It's going to be a number that's the sum of all of these, right? So it gives me 2,434, which if we added these up, looks like it's probably right. If you want to bust out a calculator, you can. But we're basically making a calculator function, right? Where if you inputted each one of these numbers and kept hitting plus in between each one of them, that's kind of what our logic's doing up here. It's basically saying take the previous value and add it to that last one. And that's what a calculator does. So let me get rid of this and go back
to Chris, do you mind putting that in Slack, that code snippet?
Just this stuff right here?
The one where you, yeah, I guess you said the one we're making I guess everything.
Yeah, I mean, I can put, if you just want this, I can put it in after I'm done. I'm going to leave all the stuff intact after this. I'm not going to change it after this. I think I'll leave it and then we'll move on. But yeah, I'll share this. So some numbers, we know it works. I just tested it myself. So, but I want calculate to be able to use some numbers, because maybe some numbers isn't the only function I want to write. Maybe I want to make like another calculator function of my own. Maybe that does division between a lot of numbers, or maybe it does multiplication between a lot of numbers. So it's not handling sum like addition anymore. I might want to make another one that handles multiplication between a lot of numbers. So for now, we just have the one. And again, calculate is just going to forward my array. I've changed my number of arguments to match what I want to send it, right? This is my first, even though it's multiple items, the whole thing is one item. So this is one collection or one array. It's going in and it's being named numbers array. And then some numbers is getting assigned to our function, so that now, oh, that's actually correct. Now, if I have to fix a few of these old pieces of code here. So numbers array needs to be passed to our function, because now some numbers only accepts one argument, and we're expecting that thing should be an array. So I need to pass an array as the one argument. So I'm basically going to forward like that in there. So we're basically doing the equivalent of this. But calculate is going to say, hey, whatever function came in, that's the one I'm going to call. And I'm going to just forward on my arguments. But I still have to fix these two. It's no longer two arguments. It's just the one. So numbers array goes there. And let's see if calculate will still give us back, well, not that number that shows right there, but if we did give it like 1, 2, and 3, we should still get the addition of all those together. So 3 plus 2 is 5 plus 1 is 6. And I still get a 6 back. So just with this alone, it doesn't look super useful, but it starts to become a lot more useful when we create another. Like if I was to take this code and copy paste it, and then I started changing like how it works, and I wanted to do product of numbers. Now all I have to do is change out my operator. So now I can expect that my total will start from 0, which is actually a problem when you do multiplication. So if I take my old total, right, which starts from 0, and I times it by any number, if you know your multiplication tables, if you times any number by 0, it's going to be 0. So this is actually a problem right here. If I times any number, actually, I'm going to leave it like this just so we can see what happens, that I can't just copy paste and expect all this stuff to work right away. So, but yeah, I just wanted to show that I can take this now anywhere else, somewhere else in my code. Now I can call calculate. I can pass it other arguments, and then I can pass it the function that I want it to run. And I'll show you one other way right after this. I know that this code is wrong just from having to make like things that do multiples of things. This 0 is going to throw it off. It should come out 0 no matter what we pass this array as. So it says 0. It doesn't matter what I put in here because anything times 0 is still 0. So I have to fix my logic. This isn't right. Like I need to probably start from 1 or something, right? Like that way if I did, because it would make sense. So if total starts out at 1, that means if my first item, my first item, like 1 times 1 is equal to 1. That makes sense. What we were doing before was 0 times 1, which would be 0. And actually 0 times anything is still 0. So we probably want to start from 1 for multiplying. If you ever have a code challenge that has you do multiplication, just so you know, you run into that problem. So it says 40,000. That's because I put 10,000, 4, and 1. So I did 1 times 4 times 10,000. So basically the 1 doesn't matter. 1 times anything is still that number. 1 times 4 is 4. 4 times 10,000 is 40,000. So you can see how calculate becomes more flexible. I'm almost creating a calculator at this point. But let me show you one more thing for higher order functions. I can actually define, if I do this the same way, 2, 4, wait a minute. Let me say 1,000, 500, 100. And then this argument that I'm going to put right here, it's going to look, I'll change this in a second, but does that look familiar? Like, does this thing look familiar? The syntax of this? I can say, am I doing this right? Make sure I'm doing this right. Oh, I actually can't. That's funny. I would actually have to repeat this. I'll do it anyways. Doesn't look as nice, but that's funny. I thought I was going to be clever there, but I'm not. I'm basically writing a function in as my I'm passing in an argument that is a function, or an ES6 syntax function. Oh man, I can't do this in this line right here. This is going to be rough to do in one line, but I could expand it out, I guess. Now I'm questioning whether I wanted to do this. Here, let me take this body right here and I'll copy it, and I'm gonna change it to subtraction basically. So we'll take the first item. I'm basically making this function right here, in this inline function, subtraction. So I'm going to write the logic for subtraction real quick. If I grab if I make our total start from the very first number, and then we skip the very first number because we already stored it, I can now do subtraction. So I can say, take whatever the total started with and then subtract the next item from it. And this might have been a lot to write out just now, but whoops. I didn't call it, did I? Or I did call it. Nums is not defined. That's because oh wait a minute. I think I tricked myself here. Numbers, nums. Oh, okay. I tricked myself there for a moment. Okay, so the parameter needs to line up with the names inside. This has 400. I don't know if that's right. Let's look. I passed it. I'm basically, this first line right here, basically, I'm taking this very first item and making it our starting point total. Our initialized total starts from the very first item. And then our loop actually skips the first item because I said start from 1 instead of 0. So I said, all right, I've already stored this. I want to grab everything like after this point. I want to iterate over all of the items. So it starts from 1,000. It subtracts 500 from 1,000, and then which leaves us with 500. Then it subtracts 100 from 500. So we do get 400. So that's correct. But I just wanted to show this. Like, this is a weird thing, right? But it's the equivalent. It is the equivalent of me saying this. Like, I can literally write a function, and you'll see this a lot in JavaScript. You'll see folks pass nameless functions in, because this whole entire function is going in and being assigned to our function. It's actually getting a name once this function receives it. So this nameless function right here is getting assigned as we call calculate. It gets assigned to this. We're still treating it the same way. We're just passing it like it's its own data type, because a function is basically like its own data type. I don't know if I should leave this in here. This one might be a little bit more confusing than the other two, like just doing it explicitly this way. But I can leave it if you want. So nameless function with a body. I'll just put that in there. So basically, as I called it, I just passed a function object with a body. I didn't assign any kind of name to it, because at this moment I don't care. You're going to see this a lot with something called callbacks in JavaScript. You'll see people pass nameless functions, and they get called by something else later, just like this. It's very popular to do. So the other one, I'll make a copy of this real quick, just so you can have the side-by-side of, the fat arrow function, basically. This thing is called the fat arrow function. It's just like a nameless function, but it's the ES6 syntax way, right? It's this, but I just didn't do the assignment part of it, right? I basically just did everything that's to the right of the equal sign. So I did the parentheses. I said it's going to accept these parameters, and then this part is like this is where you can define like your body, and that's basically what I did down here. If you see the pattern here, it's everything to the right. I actually have to put nums in here because these rely on that parameter, but everything to the right of that equal sign, this is the fat arrow function. This function right here and this function right here, these two different ways to define the function, they're exactly the same thing. So right now, while you're learning, just pick whichever one you like more, but just know that you're probably gonna see a lot less of this way, and you're gonna start seeing a lot more of this way as you progress in JavaScript. If you stick around JavaScript, you're going to see the ES6 syntax a lot more frequently, and folks are going to be leaving, probably leaving this way alone, because it's kind of like the old style of writing a function. All right, so I'm going to stop there with demonstrating just like passing functions as arguments, and let me move this down. Yep, I'm gonna stop talking about these higher order functions, and we can find. Oh, it looks like I have 5 minutes anyway, so we can pick a challenge to review again. I'm gonna try to not pick a challenge that has so many like a multi-part step thing, because I still want anyone who's trying to keep up with everything to be able to follow the challenges that we go over. That one we did yesterday was probably pretty rough. Totally making assumptions. I'm not that anybody can't do these, not that it's too hard for anybody, but it is a lot to touch on for a bootcamp prep class. but it is something that you would go over again. All of these challenges that you do right now is something that you'll definitely like interact with again and again. Like you'll have multiple times where you get to practice again and again, especially if you go through the like Platoon cohorts. So could you show us a little side by side of the two function styles? ES5 and ES6. Yeah, so you have, well, there's actually there is a slide that shows it from like week 1, I think, that does the side by side for the functions. I think it's this slide. So inside, or session 2, maybe? No, it is session 1. So if you have the link to the slide, if you don't have this link to the slides, I can give you the link to the slides. But here's the ES5 ECMAScript 5, right? This is the old style way. This is called an anonymous function, or everything to the right. Basically, this one I've assigned it's given that name, right? But we're always talking about what's to the right of the assignment operator, the equal sign. This is a nameless function or anonymous function. It has no name, but to the right of the equal sign, it has no name, but it is being assigned to a variable, which therefore technically gives it a name. But prior to the assignment operator occurring, or like before it ran this full line, this was technically a nameless function, which means you can pass this, everything to the right of the equal sign, you can pass that as an argument. That's exactly what I did right here, right? Like I didn't assign this function to a name. I didn't set it to a variable. I just kind of defined it as I called it. Like I called this calculate and I sent it in at the time that I called it. So yeah, this is like a nameless function or an anonymous function. And this is the same thing as doing this, because this right here is technically an anonymous function, a nameless function. It has no name until it was given a name right here. And this, I did this exact same thing right here for the other one. I defined it as I passed it in. So you can do this, and you're actually going to see this a lot when you get into like web apps and writing like client-side JavaScript code, or doing callbacks. Most of the time you'll see JavaScript loves doing callbacks for things. Callbacks is like you like pass a function and then JavaScript will call it later at another time. So like once something, it waits for something else to happen, and it's like, hey, I stored this function to now, like once I get this, once this action has been performed, now I can use my callback function to call it. And that's kind of part, like that's part of what's happening. It's part of what's happening right here. I'm technically calling this function, but it's immediately calling it. It's not waiting for anything else. Like there's no wait time here. So it's not really a callback. It's not classified. A callback would be like a certain amount of time occurs, like you're waiting for something and then you call, like something much longer of a process has to happen. So this itself isn't really a callback, but it's starting to look like one. And callbacks are kind of down the road. You'll learn more about those too. But you really want to concentrate on just understanding that you can pass a function as an argument to a function, and that function can call it can treat it just like it's any other data type. It can treat it like a string or a number or an array or an object literal. It treats a function as if it's just another data type that you're working with. And that's really what your takeaway should be, is like functions are just like a data type, and you can treat them as such. Like you can assign a function to a variable, you can pass it as an argument. I didn't show you how to return a function. I can show you that one if you want to see it. It might add a little more complexity, but it gets into another topic that I don't want to touch on. But yeah, we could totally do it. So maybe I can do it without making it too confusing. I'm going to comment this out just because I don't want to lose it. I don't want to change it and lose it, but I'm also going to Okay, I'm gonna get this out of our site for the moment so it doesn't confuse anybody. I'm gonna change this function real quick, just to show you that we can do a few things here. I'm gonna call it, right? I need to pass it the same things. I'm gonna put spaces so it's easy to read this. 1 and 2, and we'll use some numbers is what it expects, right? And I misspelled calculate. So if I get my result out of this, so here's one thing you can do. I can return the call to another function, right? Like I didn't have to store a variable. This function, whatever this function is, as long as it returns, it's kind of as if we're returning a return value, right? Return total basically came back to calculate, and calculate's going to return the return value of the other function. So I can do this. Whoops. This call has a return value. It's going to put it in its place right here. Like it's going to fill everything I have highlighted with the return value. But this, and then this whole statement right here will get evaluated, and it's going to return that return value. So calculate is kind of just like a proxy at this point. It's like when you call me, I'll call it, get the return value, and then just pass it through me, basically. That's what's happening. So let me just show you that will still work. Oh, I already called it. So we're gonna run this. Let me make sure I don't have anything else running. I am calling these. All right. I'm gonna comment all of these out. I don't have to comment that out. So I just want to see this in my console. I don't want to get interfered with anything else. It says 3. 1 plus 2 is 3. I passed it some numbers, so that's right. It's summing up the numbers. But what happens if I don't? What happens if I? Well, this is going to make the numbers array pointless, but that's okay. So what happens if I call calculate and tell calculate to just return the function that I passed it in? This is completely pointless to do, but it will show that when I run this, I can return the function object itself back, right? Like we're back to this again. Like I literally passed in the function to calculate, and calculate just returned it back, which makes for something interesting. So I technically gave, because this function came out, it was the return value of calculate. It has now been assigned to result. That means result is a function now. It's a function object. I can treat this result variable as if it's a function object, which means I could pass result 1 and 2. Actually, let me do this right here so that console.log will do the thing that we want. So again, just to recap real quick, calculate is returning. It's basically just doing a return of some numbers. So result is some numbers. So I can just pass in, right? Is that easy to follow right there? I mean, it's pointless to do, but it might be easy to follow. We're kind of ignoring, we're not doing anything with this value, but this just shows that you can pass in a function, and your function can actually return back out a function. So let me do something else that maybe we'll still do our results in here. So I'll pass the number array into the function. I will get our total, and we're going to call calculate like we originally did, but I'm going to return a function out of here that maybe does something with this total. So it's gonna it's going to accept a multiplier, and it's going to return back a, let's see, what can we do here? A total times the multiplier. So this inner function is actually now referring to this value, but it can only do it when I have when I pass it a multiplier, which, let's see. Oh yeah, okay. I almost lost my train of thought there for a second. So this is actually getting a little more complex, but you know, if you can follow this, if you don't follow this, don't feel bad. This is getting into a little bit harder of a concept, but I just want to show that I passed a different function as the argument, and I'm returning like a function I'm creating on the fly, I guess. So let's recap this real quick. Calculate, when it runs, it's actually going to hand me back a function object now. It's not going to give me a result. It's going to give me a new function. And what do I want to do with that function? Let's console.log it first, just to kind of inspect what is this thing. And yeah. So now you'll notice that I have a function. It doesn't even have a name. It's a nameless function. It's basically this function right here. But if it's a function, I can call it. I can treat it as if it's a function. And since it's the inner function that I've returned out of this thing, it takes one parameter, which is a multiplier. So if I give it 100, it's going to try to do this operation, and it's going to console.log the result of this operation out, right? So it says 300. How did it get 300? I gave it 100. It remembered, right? Like it remembered what that total was. So I said, do this calculation, and it's going to give me back a function that multiplies my sums. So I can do some really like interesting things with this in code. Like, not only did it run my sum numbers and add 1 to 2 to create a 3, but I returned this function back, which I can like, I can do anything I want with this now. I can pass any kind of multiplier, right? So you can do some really clever stuff with this later in code, but we won't go into that because it starts getting into like closures. If you want to look those up yourself, you can. They're like an intermediate topic to talk about. It lets you create even more useful functions for yourself. But yeah, do I want to leave this? Getting more complex. Functions that return functions that reference local. Let me use the terminology, locally scoped variables. If you want to look up any more around this, you can search for, closures. If you want to go look up more use cases for something like this, let me put this actually inside our function. All right. Anyway, so I'm going to stop there because this topic right here alone, it will fry your brain. So, but yeah, going back here, the main takeaway for this whole talk right now is so that you can know that you can pass a function into a function, and just totally play with this idea of just passing a function into a function, or returning a call to a function. Maybe you don't need to go this far. Maybe you don't need to go this far as to like return an inner function. That might be a lot to do, or wrap your head around at first. But yeah, just the main takeaway of this is to know that you can do all of these things with a function. You can treat it like it's a string or a number. You can pass it around like it's this object type because I mean, it is. It really is at the end of the day an object type. So does anybody have a challenge in mind that they want to work on? Maybe we can, I was thinking that maybe because we did this employee data one that was a bit rough, I could step back to like one of the, because we were working with objects and arrays. So maybe there's like not a multi-step one that we could do. I don't remember which one of these we've already done. I think it was number of characters we've done. I don't remember if we did car trip. But if anybody has like a preferred challenge they want to go over, just throw it in the chat or yell it out. Actually, I kind of want to enforce like a 10-minute break just to give my voice a break and get some water and let everyone use the bathroom or something. I'm going to use the bathroom and grab some water. So we'll just take a 10-minute break right now, but think up like a challenge you want to do and then drop it in the chat. And then I'll be right back. So do a 10-minute break. And I need to pause the recording. Resume this recording. So yeah, these are just a couple of the places that you can go. There's a lot more where you can find more challenges. If you run out of challenges, trust me, there's so many you can do. These are free sites. You can sign up for them to do even more challenges. So this one's more fun and this one's more like interview style. So they'll have a lot of hard. Both of these have hard ones in there, like hard challenges to do. So yeah, I would give those a shot. So beyond this, once like next Wednesday is the last session that we do here, but keep going. Like don't stop doing challenges. Try to solve one challenge, like one challenge a week even. Like even if you're taking a break, try to write a little bit of code just so you can keep it fresh in your mind. Because it's really easy to take like a couple weeks off and then come back and you're like, I don't remember how to write a function when you're fairly new and you're still trying to like solidify all this stuff. It's really easy to lose it and you'll have to go revisit these concepts again. Okay, so does anybody know off the top of their head, or maybe I'll just pick one of these? I mean, any one of these. We can go over any one of these. I kind of want to stay away from anything that's like a multi-stage thing. I don't know if we'll have enough time to go over a multi-stage one again, but we can probably go over any of these other ones. We definitely don't want to do recursion yet because we haven't even talked about recursion yet. But that's another thing that you can do with functions. So recursion can melt minds. That one's a good one. Actually, I actually struggled with recursion the first time I came across it. I had to spend time, and sometimes it still trips me up, depending on the problem. But if anyone has a preference, otherwise I'll just pick one. I don't have one in mind either, so I'm just going to pick whatever. So just let me know. Okay. Nobody? All right. Let me look at this one. I don't know if we did this one yet or not, but let me fork it. Car trip miles, spare tires used. Write a function takes in a car object. The app questions have gone to a new site, CoderByte. Oh, CoderByte, yeah. Will the challenge questions do the same? These will, because they're public, they'll probably, like these, the links that you have right here, they're probably not going to go away. You'll still be able to, they're public links, so you can access them as long as like no one from Platoon like deletes the physical, like goes into this, like that account and deletes them out. So they're public links, so you can still access them. I don't think anyone's going to do it. It's not costing any money to do it, but they are moving. I believe they're moving to CoderByte for future. They're moving to CoderByte for future like application challenges because REPL, this website, they got rid of a product that Platoon was using. So it started to they're basically getting rid of the classrooms product, which is what we use to like give you code challenges, but also let you test your own code challenges. So that testing portion was in there, which now we don't really have. You just have to kind of like test it yourself, which is unfortunate. I would much rather have test cases in here so you could test your code, but that means I would have to go manually write at least 49 different test cases for every single one of these, which it would just take time to do, but it's possible. But yeah, they're moving to CoderByte because it'll let them write in the tests for everybody that forks one of the challenges. But yeah, there was they just got rid of a product, so we just weren't ready to swap that soon. Translate all those challenges over. Anyways, so I'm just going to go ahead and do this one since no one had any recommendations. Okay, yeah, just making sure I can hear. Update. So write a function that takes in a car object in the form, and you'll notice that it's trying to hint at you with this this red highlighted. It's basically trying to highlight code, what looks like code, and like this is what the object should look like. So there should be a value to represent people here. There should be a value to represent miles, and there should be a value to represent the spare tires used. So these are basically just placeholder names for what values should be there, is what it's trying to imply. So in the form of this data. So write a function that takes in a car object, and it's going to take in, meaning a parameter. So I'm accepting an object that looks like this. It's going to have you know, people, miles, and spare tire values in there, and a number of mile driven as an integer. So it's taking two parameters. And this is what it looks like when they're going to call it. They split it across multiple lines, but you'll see that the first parameter is our first object. And this is really picking out data types. So you have to make sure you're paying attention here. So this outer one is an object literal, has key value pairs, right? So this whole entire object is going in as whatever the first, here, let me go over here. It's going in as, so like car right here is gonna be like this object that has people, or wait, what did it say? It's gonna be this object that has, okay, so those are keys, not the values. So these are keys mapped to values. So I'm gonna copy this whole thing just for the example, just because I wanna visualize what I'm working with here. Let me do this across. I'm either going to get one really long line or multiple lines here. I'm going to do one long line. So our object's coming in and it looks like this. I'm not splitting it across multiple lines. So the key people, it's mapping to a value that is an array of strings. So keeping everything in mind here, we have an object literal is car, which contains a people key that is an array of strings. So I'm just kind of like mapping out all my data types, because this is what I'm doing in my head, but I'm like, you know, stepping through this slowly. It has a miles key, which looks like it's a number right here, and spare tires, which also looks like it's a number. This is everything that my brain immediately does when I'm looking at code. Why am I saying keys? Keys. And I'm saying key because, again, this is a key. This whole thing is an object literal, making the thing on the left side of the colon a key, and the thing on the right side of the colon, the value mapped to that key. So people is a key, miles is a key, spare tires used as a key, and this value, each of these values goes with, it ties to that key so that we can talk to the object. So that's a number. And then the next thing, I'm just mapping these out step by step. So number of miles driven as an integer. It says update the car object to include the new amount of miles on the odometer. So I need to represent an odometer in here. Additionally, the road is very rocky, so you'll need to use an additional spare tire every 1,000 miles. Update the car object to reflect this too. Okay, so I need, this is gonna be a decent challenge. This is definitely gonna show us how to like reassign to this object. So just looking at inputs, like this is the way they're trying to call our object. I'm gonna take this whole thing into our code. Actually, you know what I didn't do? I didn't copy the instructions. I didn't do my usual thing here. All right. Okay, what was I doing here? So looking at the inputs, I have two inputs. The first one is a full object literal going in as the first. The second one is supposed to be representing number of miles driven. And so it said in here that the miles, this is the miles driven. We need to update the object that was passed in based off of this other value. So I'm going to pass in an object, I'm going to pass in an integer, and then I'm going to perform some actions against this object. So I need to update the car object to include the new amount of miles on the odometer. So I need to take this number, and whatever this number is, I need to like increment miles to that. So that needs to become like 7,000, right? So the 500s together make 1,000. So that becomes that's going to become 7,000 if we add them together. But it also says there's one other case. The road is very rocky, so you'll need an additional spare tire every 1,000 miles. So not only do we have to add these two together, but we have to somehow do a calculation to figure out how many spare tires were used. And it told us right here specifically every 1,000 miles. So if we have set, let me map this out on the other side because I don't want to just talk at you the whole time without showing my thought process. So again, this is them calling it, and then this like little syntax right here is supposed to be reflecting that this is what they expect to get back. So if I called your function like this, I would hope that your function gives me back this newly updated object right here. That's what it wants back. So yeah, so input and output. These are my inputs. My function needs to return a new output based off of these inputs. So I'm still getting back the people, Spider-Man and Batman. I'm getting back my incremented miles. So you can see that these two were probably added together. And then spare tires went from 0 to 5. So they did some kind of calculation to determine how many spare tires were used. And every 1,000 miles, that counts as one spare tire. So we can come over here. Let me comment this out because it's not going to be, well, let me comment this part out and put expected return value. This is the expected return value for this call. If I change any of these values, then this is no longer going to be the case. But we're going to use this to test it with. And I have plenty of time, I think, to do this challenge. So we can take our time. Y'all can totally ask questions if I lose you. And yeah, let's go. Let's think this out. So I eventually want to return some object here. Actually, I want to return the original car object, but an updated version of it. So immediately, the first thing I'm going to do is like this car object, which is this thing. This car object is storing this thing, and I want to return that, but I need to update it prior to returning it. So for the first thing I'm going to do is make sure that this function will run. If I send it this, it will run currently as it is. It's literally just going to give me back whatever I passed in at the moment, which is perfectly fine. Let me do this. Let our result. We're doing a function call here. I know this looks kind of, this is, I don't know how readable this is to just look at. I'm going to break this up into two sections. I'm going to put our data, or maybe call it trip data. Oh, that's not the right thing I wanted to paste. I'm going to put this separately, right? Because this is our object literal. And now instead of doing this multi-line stuff right here, I'm going to actually move it and say trip. I'm going to pass it in just so it looks, it maybe looks easier. I feel like it looks easier to read that way. So, and then I'm going to console.log whatever our function call car trip returns back. So this return value, whatever that is. Right now, I haven't updated anything. So I should literally get back what I passed in because I updated nothing. So I expect to see this right now. And so I get Spider-Man, I get the 1500, I get tires. I get exactly what I passed in. That's perfect. I know that at least right now the function works. So let's see if I break it. So the first thing we want to do is we need to update an object. And we kind of talked about this when we went over object literal session. So to update an object literal, we can actually combine the use. I can access a key, right? If I wanted to update, car is the object. If I want to update the value that's stored inside of people right here, right now it's currently an array, just to show you that this is a way that we can update values. Watch what happens. This is kind of like review. You see what happens is it actually replaced what was in there. Now, I don't want to do that. I don't want to replace what's in there. I want to use what's currently in there. And then I want to perform some calculations and then update the value with those calculations. I don't want to just fully replace an entire value like this because that's not what it's asking us to do. So I don't actually need to touch the people key at all, but I was using that one as an example. But it did say, I'm going to break this into steps. So update the car object to include the new amount of miles on the odometer. All right, step one. Additionally, the road is very rocky, so you'll need to use an additional spare tire every 1,000 miles. Update. Okay, so it's really just two steps here because I already am going to return this car when I'm done with it. So I need to update the miles value. So I need to change this to miles. Let me put that code I had in here. How we can update an object literal. I'm trying to keep the comments in here so I can copy paste this in and not have to modify too much. For those of you who like these code snippets. All right, so miles is the thing I want to update, just like I did in the example up there. But car miles equals, and we can do that same thing we've been doing where we say, I want to take the original value of miles and I want to add it together with the thing that it asked me to add it to. So I want to include the new amount of miles on the odometer, and oh, here's where it was at. So it said, write a function that takes in these two objects, right? The second thing coming in right here is how many miles were driven, and I need to update my object literal that's supposed to be representing my car, like attributes of my car, like the people in my car. That's basically what this object is doing. I'm trying to represent who's in my car, how many miles my car has driven, and how many spare tires of my car I have used. So we're using an object literal to try to like represent a car in code. And I need to take this second value from the parameters, like how many miles were driven. I need to take this is like the car's miles odometer, like the inside the car in the dash, the odometer reading of how far you've ever driven in your car total. We're basically trying to represent that and increment it. So even though inside my object I have a key called miles, this miles right here is this miles, like it's the miles that came in, but this miles is actually referring to the key inside of this object, inside the car object. So keep that in mind. Don't get this mixed up with don't think that I'm passing, don't think that these two are referring to this miles in any way. It's actually a key that's embedded inside the car object still. So I'm going to leave it at that, and I want to run this because these are just 2 lines of code. They're valid. I want to see what happens when I run my trip data example, because I'm basically expecting to see people on Batman because I didn't modify it. Miles should be updated from what I'm hoping that it's updated because that's what I'm trying to do. Spare tires, I didn't write anything for. It should still be 0. So when I run it, I can see that my key for that is the same. Miles has been updated to 7,000, which is what we wanted. So that was pretty easy to do. Now we just need to do this. We need to think out the logic that we need to do for how to do this spare tires thing. Like I kind of need this value right here, whatever it is. And I need to determine how many spare tires are meant to be used. So let's reread this again. Step 2, the second part of this. The road is very rocky, so you'll need to use an additional spare tire every 1,000 miles. The car object, update the car object to reflect this. So I want to say, if I think of it, says 5 here, so I'm just thinking about what math operation that I can do where I would have gotten 5, but there's none that's going to give me this, because if I take 7,000, right, like if I say, I can use division, and if I think this out, right, if I say, actually I can do it in the console right here. So JavaScript console, I can do math. So if I take 7,000 and I say every 1,000 miles, I need a spare tire. I need the spare tire count. I could actually divide 7,000 by 1,000. Gives me 7. So I would have used 7 spare tires. But if we read into this, it's not obvious, but if you think about it, maybe it is. So I actually have to, this isn't actually what it wants, right? We can tell by the return value, spare tires needs to be 5. So I don't want to do my calculation on miles after I've updated it, because it said you'll need to use an additional spare tire every 1,000 miles. So I'm thinking that what they mean for it to happen is that whatever this car was at, we're assuming that a spare tire, we don't want to include 1,500. We want whatever the miles driven were, we want to divide into that instead. So whatever the car object was currently at, we're assuming that the tires are good from that point, and then every 1,000 miles after that. So either either we need to just take the miles here that was passed in, or if we wanted to still use car miles here, this is us updating the miles value. Well, let me say car miles value to the new value. If we do it here, this is when it is 7,000. So we can't just divide by 1,000 here. That would give us 7. That would be wrong. We need it to be 5. So what was the number that came in? 5,500. All right, so 5,500 divided by 1,000. That gives us 5.5, but it's a 5. So what looks like happened is they didn't care about the decimal. They just wanted, because if you think about it, you can't have half of a spare tire. I mean, you could if you like tore it up or something maybe, but a usable tire. So it can't be half a tire. We have to only consider whole tires, whole numbers for tires. So it has to be, if it's a decimal, it just has to be the leading number, because it can't be it can't be 5.5 tires. So there was a thing we learned about 5,500 divided by 1,000. That gives us a decimal. And I think we actually used this yesterday. It was parse int. And it was the built-in parse int function, which kind of strips off the decimal. So that will give us our 5. And that's the 5 that we want. So this is kind of like this is actually the formula that we want. We have every 1,000 miles, we have to change a tire. But it's every 1,000 miles only applied to miles driven. So we don't want to add the current odometer with miles driven and then do the calculation. We have to do it before that. So for this challenge specifically, this one is actually maybe less complicated than the one we did yesterday. So there's 2 things I could do here. So car miles at this point is 7,000 divided by 1,000. Divide our new mileage by 1,000. Not our new mileage, our miles. Yeah, miles. So there's 2 things I can do here, right? Because miles, well, there's one is kind of like defeating the purpose when you already have access to the other value. I have access to the 5,500 coming in right here. I know I broke down object literal is car, but I didn't say what miles is. For our example, it's 5,500. It's a number. I have access to 5,500 already, so I don't have to do any I don't have to resubtract any numbers here. To get my original 5,500, right? I have access to it. So why do that? I could just say miles divided by 1,000, and this would give me my 5.5, right? It gives me miles is 5,500 divided by 1,000 gives me my 5.5. I can parse int off of that, which gives me my 5 by itself without the decimal. So this calculation right here, I need this, but I need to update my key also at the same time. So I actually can do this. I can say, what was it called? Spare tires used. I want to basically add this. I want to do this calculation, this division, whatever number that is. I basically want to add it to that, because you have to think about this. I'm saying add instead of assign because there's 2 things that I'm already thinking ahead. Let me not think ahead. Let me just do it the assignment way, kind of like without addition, and I'll show you. I'll show you what happens, just so I'm not jumping ahead and thinking here. So I want my spare tires to equal this number, but I'm doing assignment here, which means that I'm literally going to assign this to whatever this calculation was and not consider anything else. Like whatever miles is, it's going to get divided by 1,000, and that is what that returned number is going to be my value. And I'll show you why this is a problem that I can foresee, that you just from programming enough to know that I can break the expectations without breaking the code, if that makes sense. So yeah, let's run this real quick. I want you to see the new output of this object. So we still have Spider-Man and Batman in the car. 7,000 is the right number we were expecting, right? This is our expected result. And then we have 5. So we've technically solved the challenge, but was there only one example? There is only one example. So I would take this a step further. If there's not more than one example, or always try to invent at least your own version of the same example just to test things. What happens? I'm going to change some numbers around here. So I'm just going to modify our data. I'm going to say we started from 2,500 miles. So I don't expect I don't expect I think I'm going to leave 5,500 the same, because I kind of want to make it apparent that this miles didn't come into play for the calculation, right? So our current car odometer is at 2,500. And even though this number is going to add to it, so we will get a bigger number, spare tires should still be 5, even though our car has an odometer reading at a higher level. But I'm also going to change one other thing, which is spare tires isn't going to start from 0. Let's say I've driven 2,500 miles and I've already used one spare tire. So this is kind of representing the state of my car. This object literal is trying to like pretend. We're trying to pretend, well, not really pretend, but we are representing a car in the sense of a few attributes, like the people driving the car, the odometer reading, and how many spare tires. We're just representing this one car, right? Let me run that. So it still says, well, let's go through these. So now I have 3 people in the car. My odometer reading says 8,000. Let's make sure that's right. I started from 2,500, and then I added 5,500 to that. So that's makes 7, and to the 2 5s make it 8. So that's right. Spare tires used. If I sent 5,500 in for the miles, we're supposed to ignore the odometer reading because we're only dividing into the miles. So that says 5. So it should be 5 on top of what I've already used, right? It's not remembering this 1, whatever the original value was. And that's what I was saying about this thing is like 5 is what gets returned here. If there was a 1 in spare tires before, it's gone because I reassigned it. And the same thing would have happened here if I didn't reference the original value. So I just need to do what I did above. I need to reference our original value that was in there like that, and then add my 5 to it. So if it was 0, it will still be 5. But if it was 1, it should be 6. And that feels more right to me. Hard code a +1 into value. No, we don't have to hard code a 1 into it because, well, this 1 is coming from whatever I decide. Maybe I used 10 spare tires for some reason, but now I expect, let's run this a few times. So I have 15 spare tires because my spare tires is purely based off of miles driven. So if I did start with 0, me changing the miles driven, like how far did you drive? I drove 1,800 miles. In my head, I know that if I drove 1,800 miles, I divide that by 1,000, I should have 1 or 1.8, but I'm stripping off the decimal. So I should get a 1 for spare tires used. So my spare tires depends on this second argument. If it's 2,200, I'm dividing by 1,000, I get 2. So it's kind of like a perfect division case here. Sorry, there's questions. I'm trying to get into Oscar Platoon, just not ready. This live course has been great. Put off studying. Yeah. So it's good to. I joined Code Platoon. Sorry, just to sidetrack real quick. I kind of had a similar situation, right? So just to sidetrack for a moment, because we have pretty much completed this challenge. This one wasn't as difficult as yesterday's, but I joined Code Platoon because I already had experience, but I found it really hard to dedicate the time to learn React, and that's what I really wanted to learn was React, but I could never make time for it. I would never intentionally make time for it. So what I did was like, my last company had layoffs, so I had time that freed up. And then I was like, okay, there's like a couple things I can do here, right? Like I just learned about Vet Tech, a program for veterans. I was like, this actually it kind of works like the GI Bill, gives you housing allowance. I was like, perfect. Like I don't have to work, or at least I'll get a housing allowance so I can survive a little bit longer. And then I can do this program and get React nailed down, because if I sign up for Code Platoon, I know for a fact putting myself in like a classroom setting that just my personality trait, from my own pulling from my own experiences, if I put myself in the scenario to have to do the class, I'll do it. But with a bunch of free time on my hand, there's a good chance that I'll sidetrack myself with something else. That happens all the time. So I was like, I'm going to sign up so that I have to do it. Cause I know I'll see my way through it. And it's pretty much what I had to do too. So like, you kind of just have to say, do I want to do this? If yes, let's go for it. Like, it's going to be hard. You'll figure it out along the way. So you just have to commit to it. If you're able to. I don't want to tell somebody to like commit to it if money's always a thing. Like some people just have to work. Like it's not easy to make the time to do a full-time course. I had the ability to do it. I had like a window of opportunity, and I told Code Platoon, I was like, I don't know where I'm going to be in 6 months from now. I don't know if I'll have the time to do it. So can you guys get me into a course fairly soon, last minute even? Because I know I have the window right now to do it. And that's what happened with my case. They were one of their students dropped out of Lima Platoon, and I filled that spot on a very last minute basis. But I also prefixed them with like, I have experience, so I can catch up. I have the ability to catch up. Sorry, just sharing experience for everybody else. If you're questioning whether to do it or not, like if what we've done so far is interesting, if all the challenges, doing the challenges feels, if you like it, if it's just like tickling that side of your brain, like this is kind of fun. Doing challenges is kind of fun. If you want to learn how to build web apps, you're going to learn how to build web apps. There's no way that you can do Code Platoon all the way through for 14 weeks and not coming out and know how to build a web app. Like there's no way. You're going to do so many challenges and learn how to program along the way. And it's going to be so much content, and you're going to feel like you're not retaining much of it. But by the end of it, you're going to be surprised at yourself. So there's no way you can do 14 weeks of coding and not have takeaways. If you're like mentally committing yourself to it. The only way that would happen is if you just did not try. If you just like didn't show up and didn't try, then yeah, you're not going to have any takeaways. But if you show up and try every day, you will have takeaways. You will learn more than you started with. Guaranteed. Yeah, we're pretty much done with this challenge. I still have 50 minutes. I could technically go over another challenge if y'all want to.
Can you do hot potato types?
Hot potato types.
Are you going to put that one you just did in Slack?
Yeah, I'll drop them both in Slack. So you can mess with those hot potato types. You spend a lot of time watching tutorials. Let me tell you, when I first started, the first thing, this is going back to like over 10 years, about maybe like 10 years ago, when I first started learning how to code, for real. There was a time before that when I was younger where it wasn't for real. I was just trying to do stuff. But when I was taking it serious about 10 years ago, I was learning PHP, and I was trying to learn from all the free resources, right? Like anything that's not paid for, trying to get by with YouTube videos or articles I could find on the internet the whole time. It only gets you so far. There might be better options today for free sources, but during that time, there was not a lot of good best practices. But I did learn stuff, and I had to watch and rewatch so many tutorials to get through it. Just to like try to get my mind wrapped around what the heck they're talking about. That's like the hardest part, is like understanding what they're talking about with all these like concepts. Like, what are all of these terminology is probably like the biggest one, learning what things mean, what they're actually talking about. So I had to do the same thing. Like this, it's like a rite of passage almost for developers. Is yeah, if you're dedicated to it, you'll get there, trust me. And you actually won't realize how far you are. One more side note, you won't realize how far you are until you try to teach somebody else that's brand new. Like when somebody else comes in and they ask a question like how to write a function or what ES6 syntax is, and then you go back and help them answer it, that's when you'll start to like, oh my gosh, I remembered that off the top of my head. That's when I started to realize like how much I remembered. And I was like, oh man, like this was actually kind of fun, like showing somebody else, like teaching somebody else how to do it. And then it kind of became a thing. So I wasn't expecting to be where I'm at today, but I actually like this. It's fun to teach other people how to do this stuff. All right. So I'll get to the questions here in a second, but let me start getting my thinking for this next one real quick mapped out. So I'm going to copy over all of the things again. And I like to read from this one, so I click back over here because it looks better than reading the comments. All right, so for this challenge called Hot Potato, you're the teacher of a class with 5 students. Student 0, student index 0. A first student is, you know, I see what they're doing here. It's kind of like a play on the index 0 thing. Student 0, 1, 2, 3, 4. And you want to play a game of hot potato. Initially, give the potato to student 2. And after each turn, the student will give it to the student on their right. So student 0 gives it to 1, student 1 gives it to, student 4 will give it to student 0. Aha. So you can't just use a for loop for this. So I'm already jumping ahead in my thinking. I'm like, everything that they've described up to before this, I wouldn't expect anybody else to like immediately map this to something in their head, but just to I'm thinking about code the whole time I'm reading this. So I'm looking at these like index, maybe these are hints or something, or maybe they're just making a joke, but you want to play a game of hot potato. Initially give the potato to this to student 2. So we actually have to start from student 2, and student 2 is the 3rd item. So there, it's the 3rd index in, if this is an array of students, we have to start from student 2. So I'm just thinking about that out loud at the moment. We start from student 2. After every single turn, the student will give it to the student to their right. This tells me, as I'm thinking about this, I could write a loop, right? Because if these are all in order from 0 to 4, if we started from 2, 2's passing it to 3, and then 4, I could use a loop for that much of it, because a loop can go to the next item and increment. But then you have a problem, right? Then you have a problem where student 4 will give it to student 0. The way that we've written for loops so far, they generally iterate from left to right, but they don't go back, right? They don't come back to it again. But there is a looping mechanism we can use to do that with some conditional logic. So I can combine a certain type of a loop with some conditions and we can make the loop run in this fashion. Like we can do this very specific start from 2, but then go around the circle again, right? Like that's what it's trying to have us do. I wish I had a picture for this. It might be actually easier to understand. Like this, like they're kind of going around a circle. If you've ever played hot potato before, like trying to visualize hot potato in a room with this many students. So I'm basically like visualizing the actions that the people are taking and trying to convert this mentally to what code might work for it. And so I'm thinking like a loop and some conditions, and I need some way to remember where the potato is currently at, and it has to start from 2. So all right, I've already talked enough. Let me write a method. This should be function. Write a function that takes taking in the number of turns. Taking in the number of turns and returning an integer representing the student the potato lands on without using loops. Awesome. Without using loops. All right, so my thought was to use loops. I hope this isn't recursion, because all right, I'm going to try to do this without loops and recursion. Maybe we'll find out. I don't see that going well, but we're gonna see. Once I start getting my steps mapped out, it'll be easier to visualize. I hope this isn't a recursion one, because it does say types. Hold on, let me go back here. It says types. It doesn't say recursion, so we're about to find out. Okay, so write a method taking in the number of turns and return an integer representing the student the potato lands on without using loops. I don't know how I'm going to do this without loops or recursion. And if that's the case, I'm going to have to use recursion. But let's find out. All right, so the number of turns coming in here, as our example suggests, if I passed, so if 0 happened, I should get back 2. And if 1 happens, I should get back 3, because we start at 2, and if we take 1 turn, it should be the person after 2. And if we went 7 times, we always start from 2 and we go 7 times. So it would go all the way around and come back, and it says it should be 4. If we started at 2, we would go student 3 is 1, student 4 is 2, and then student 4 hands off to student 1 or 0. That's 3 moves already. 4, 5, 6, 7. So that's correct. I just wanted to make sure that I understood that correctly. So yep. So if I passed in 7 turns, I should get back student 4. And I'm going to comment these out because I just want to run the first one. So how am I going to use number of turns to determine my player that we're landing on? So if number of turns comes in as 0, first I want to know if there's any math. Maybe there's like a math equation I can create here. If I can create a math formula that solves this, then I don't have to loop. I can literally just do some math and get a value. And if I can't come up with anything that's like a math equation, then if the only other way to avoid a loop is to do what's recursion, I don't want to do recursion, but if we have to, I will do it and then explain it. But then we're going to go over recursion next week. All right. So number of turns, if a 0 comes in, so let me map out our considerations here. Number of turns for our first example, it's going to be 0. So how do I know to get 2? Our starting point is always going to be 2. um, starting student always starts from 2. And then I'm just trying to map out this very first example. And this one like makes it look like it's easy, right? So if potato took a number of turns of 0 and I added that, if I added that number to it, so starting student plus the number of turns, I mean, I could get that, right? 0 plus 2 is still 2. So that one would technically work. So if I, uh-oh, it went idle or something. Give it a second. So this is like, if this was all we had to do, it wouldn't feel like much of a challenge. It'd be like basic math right here, right? Like we're just summing 2 numbers up. But I think it's gonna, one of these next ones is going to introduce the next complexity here. All right, I'm going to refresh the page. So this is my first step, right? So we know we have to start from 2 every time. So set a variable to 2 to start with. And then how to determine what student we land on based on turns. This is what I'm still trying to figure out. So far, we've only really solved this first step. I should have wrote these out first, but I'm still trying to figure that out because I know the next ones that we test are going to be wrong. And this is like the first case we're testing, the easiest case where there's no turns. No turns have happened. We're basically just returning a 2. So I get a 2 back. That is what I expected. All right, cool. We basically solved that case. What about this case? What happens if I take 1 turn? I get 3. So that one's solved. So what happens? So 3 actually works. So I actually solved the first 2. But this next one is not going to solve anything. So I should be able to pass a 7 and get a 4, but I get a 9. And that makes sense because we started from 2, we added 7, we got 9. So is there something we can do here with math, basic math operations that would allow us to account for this? And the only parameter coming into this thing is number of turns. We're not actually, this function actually doesn't care. This function actually doesn't care about the student count, like how many students are here. But the problem did define it for us, right? Like we have 1, 2, 3, 4. We have 5 students, and our number of turns changes based off of the number that we're returning is our index of a student. Like, yeah, it's basically one of these students, right? So let me write a method taking in the number of turns and return an integer representing the student the potato lands on without using loops. So we have 5 students no matter what, right? We're not, this isn't like a changing number. It's always going to be 5. So is there something that we can do with 5 at least? So what kind of math operations can I do here? So we know that I sent in a 7. I have to start from 2. So it's always going to be 7 plus 2 that's 9. Is there something I can do with a 5 to get 4 from 9? So I could do subtraction. That would give me 4. So if I So far, if I subtract 5 every time, it might fix this case, right? But is it going to break the other two now? So if I just did -5, because we always have 5 students, I get 4. So this one passes my assumption, right? I get 4. But now, since we changed the code, we have to retest these ones. So what about 1? Now I get a -2. That's not going to work. I can't just subtract 5 no matter what. So that makes me think that I might be able to solve this another way. I might be able to combine maybe a conditional, right? Like if our starting student is always 2, I'm trying not to use any kind of modulus yet either. FYI, Neil. I've seen it, but I'm trying not to use modulus yet. I'm trying to see if I can solve another way. So we always start at 2. 2 is our first student. And then when we hit 4, I'm just trying to mentally visualize this. We start at 2. If we take 1 turn, we hit 3. If we take 2 turns, we hit 4. If we take 3 turns, we have to end up back at 0, basically. So if we take 3 turns, we could actually represent that too. We could add in our own test case of our own making, because I just mentally did what the logic says. So 1 turn, 2 turns, and then 4 has to hand back off to 0, so 3 turns. So this should technically be 0. I'm kind of creating here. Let me kind of creating my my own test case. Well, this really isn't a test case, but my own assumption to test. Right? Based on the prompt, this is what I'm assuming is supposed to happen. So I'm just giving myself one more thing to test. We start from 2, and if my turns has become 2, this works, right? Like this adding operation will still work. But the moment I hit 3, the moment I hit 3, this adding operation no longer works, because if num of turns is 3 and the starting student is 2, 2 plus 3 is 5. I have 5 students, but it starts from 0. And I'm really just trying to think out this out loud so I can try to like see if there's something I can do in here with this. So after 3, so if num turns is anything greater than 3, it seems to like break. If it's greater than 3, it breaks my potato game, basically, because we always start from 2. 1, 2 is fine, but 3 I have to start from 0. So after 3, I can't really add anymore. I have to do something else. So if my num turns is, we can write this 2 ways. I can say if it's greater than or equal to 3, or I can just say if it's greater than 2, because anything greater than 2, well, 3 is greater than 2, right? So if it's greater than 2, so 3, if it's 3, I don't know which one looks better. I mean, we can use either one of these. So if I do that, if it's greater than or equal to 3, then maybe we need to do something else. Otherwise, if it's the other side of this condition, right? Like if it's the else side of this condition, I can just add, right? So maybe, so if this plus this is more than our current student, however many students we have, if it's 5, basically, that's a problem. So if it's greater than 5, maybe I can do this same operation right here, but since the adding of these two together makes 5, what if I subtract 5? Because we always have a constant of 5 students. So if I take 5 from 5, I get 0. And if hopefully that all made sense, like going through that step by step made sense, because if we think about it, right, student always starts at 2. That means immediately if we take 3 turns, we have to end up back at student 0, the very first student, because 4 has to hand them back off. So I'm basically saying that if the sum of our starting students number with the number of turns is equal to our student count, like if it's equaling how many students we have, well, it's technically going over. If we have 5 students, but it starts from 0, but it's still 5 students, 5 minus 5 would be 0. Is that actually, is this right? Let me work out the logic for that. Like what if, oh, no, it is right. Sorry. I started thinking about 5 as an input. So when number of turns is 3, that makes this result 5. And if we subtract 5 from 5, it's fine, right? So does this work for every case? I just want to see if it works for our first 3 cases, because that's what we were testing first. So let's make sure that 0 still works. It should still be 2, hopefully. Oh, I did something wrong. What did I do? Line 22. So line 22 is broken, and it says, it says it doesn't like that. What did I do? Why can't I use a strict? Really? Did I make this up? I don't think I make it up. I'm pretty sure I taught this to you guys. So JavaScript operator is strict. Oh, they don't use the triple for it? Man. I'm pretty sure I put that in a slide. I think oh yeah, so not equals. I think I need to fix a slide, because I guess I could always do this. Yeah, that doesn't exist. Cool. So anyways, I totally need to fix a slide. We can't do, so this is a thing. This is a thing. That's not a thing. That's good to know. It's not even a Python. I can't even blame Python for that one. So Python doesn't do triple equals. That's just me simply forgetting that we don't do that version. I don't even know where that came from. All right, so it says 2. So 0, we passed in 0, we got back 2. So that is still good. Nothing I did there has broken that. And if we think about, if we step through with 0 in mind, right? Let's do the math for that. Number of turns is 0. Starting students is 2. This num of turns is 0. So it's basically as if we put a 0 there. So 0 greater than or equal to 3. That's not true. This will not run. So that means the else will run instead. So as long as num of turns stays less than 3, we will just simply do addition. But the moment that this 3 is equal to 3, or if it's greater, so if it's 4 or 5 or anything higher than that, right, then it's going to do this operation, but also subtract the 5. So it's going to do addition if that's a 3. So 3 plus 2 is 5 minus 5. That makes it 0. So let me put that back. We'll look at 1 what 1 is now. Before I run it, we're expecting a 3. Let's kind of do the math ourselves to make sure. I mean, we could just run it and see what we get and then try to think it out, but it's almost better to pretend for a moment that num of turns is 1, starting students is 2. So this is like a 1, which means that we're going to do 2 plus 1 right there becomes a 3. And that still works. Whoops, I was going to paste it, but I'll just fix it. All right, so keeping our code back to the way it was, that works. Let's see if 7 still works. 4, so we still get a 4, and if we go, we can do that one too. I think we did this one, but we know that 7 plus, starting from student 2, 7 plus 2 is 9. And because 7 is greater than 3, it's not equal to it, but it is greater. So 7 is greater than 3. This is a true statement. That means the else won't run this time. This one's going to run. I don't know why this doesn't say types and control flow, because, you know, it feels like this is the easy way to go to solve this one. But you might be able to solve it with modulus too. We could have a look at that. And let me test. I put these ones in here so we could test it. So 3 should technically be a 0. And if we think about it, if I put a 3 here, or wait a minute. Yeah, so if we put a 3, 3 plus 2 is 5, and 3 right here would be equal to 3, so it would run this. But remember that this is doing 3 plus 2, which is 5. So 5 minus 5 is 0. So I think that would work. Let's make sure that it works. Let me put them in order. And I'm expecting a 0. We tested this one, it works. Oh, I left it commented. So 0, we got a 0, so that one works. Now, I'm going to test this one more case, and then I'm going to put a much bigger number in there. Well, maybe not too big, because I'm going to have to mentally figure it out. But we'll pick a slightly larger number. So 5, let's think about 5 in here. 5 plus 2 is 7. So 5 would go there. 5 is greater, as I read the statement, 5 is greater than 3. So we would say 2 plus 5 is 7, minus 5 would put us back to 2. So we would expect a 2 here, but I didn't actually work this out in my head. So I'm assuming that a 2 would come out, and we can test this real quick to make sure that it gives us a 2, because it's what we expect. But I still need to do one more thing. Whoops. What was it? 5? It was 5. I left 3 in there. So let's put 5, and our expectation is it's 2, and we don't know if it works yet. And it is 2, so it works. So all of those work. So this is looking good so far. And I just want to double check this one to make sure that even though I worked it out in my code right here, I need to make sure that it actually fits inside what they want. So we start from student 2, we have to go 5 turns. So student 3 is the first turn, student 4 is the second turn, student 0 is the third, student 1 is the fourth, and student 2 is the fifth. So that's 5 turns. We come back to student 2. So we do a full cycle. With hot potato, we basically do a full circle. We have 5 students. If I start from student 2 and I go across to all 5 students, I should end back up at student 2. Makes sense. Let's put a bigger number in there. let's just I'm not going to write it all the way out again, but I'll at the very bottom, we're just going to pick technically, if I stick to 5s, if I always use a 5, right? If 5 gives me back 2, does 10 give me back 2? 15, 20. If I go by fives, I should always get back the same student. What if I do 25? I get a 22. So I am breaking something at some point, a bigger number. If I took 25 turns in hot potato, at some point our code doesn't recognize larger numbers, right? So that's kind of an edge case to account for. So I've accounted, my if statement only accounts for the low side. It's saying, do this when my number of turns is greater than or equal to this point. So it's accounting for like the low side, but it didn't really account for any high side. Like it doesn't know what to do in the case of huge numbers. So we have to find the point when it breaks, really. Like at what point does 10 break to? Gives me 7. I can't have 7. This return number is supposed to represent what student we're on. We don't have a 7th student. This can only be 0 through 4. So when does it break? 7. So I know 10 is broken. So now I'm kind of just doing like and between 7 and 10 is when it breaks pretty much, because I know 10 breaks. So what about 8? 8 gives me 5. I don't have a 5th student. So 7 works, 8 does not. And, 9 gives me 6. That also doesn't work. So we know that 8 and up is actually breaking our code. So how would we account for high numbers? And we can't just do a subtraction of, we can't just subtract anymore, because this number can literally be anything. How much time do I have? I have 15 minutes. All right. So we've accounted for, else basically accounts for 0 to 2. Because if it's 3, this accounts for num of turns being 3 or higher, but breaks at 8. Works up to 7. So that's kind of like this case, like this weird case that we have right now. Num of turns works for, runs for 0 to 2. So this one's trying to handle things that it can't, this math equation can't handle. Like it breaks after 7. It works up to that point. And that's because that's really because of our addition, right? So if I pass in a 7, if you think about it, I pass in a 7 turns, we're gonna always add 2 to that. And I'm always gonna subtract 5 from it. 7 plus 2 is 9, minus 5 gives us 4. 4 is our highest student number that we can have. 0 through 4 is all of our students. We can't go past 4. This doesn't account for that. So the moment I put in an 8, 8 plus 2 is 10, minus 5 is 5. Can't have that. Some other operation has to happen here. So we could say, all right, what operations can I do? 8 plus 2 gives me 10, right? Let me do it. I'm gonna put these in parentheses so it will actually, or I can just do 10 like this. So let's assume I did 8 plus 2. Can I divide by 5? So if I go over 7, if I divide by 5, I get 2, but what is 2? Is that the right number? If I divided? If I start from 2 and I go 10 turns, right? We kind of already talked about this. 5 turns is 2, which means 10 turns starting from 2 should actually end us back up at 2 again. But let's do it. 2, 3, 4, 0, 1, 2. That's 5 moves. And then if we did 5 moves again, so 3, 4, 0, 1, 2. So 10 turns, I should end back up at 2. So this looks promising for the moment. So now we have to edit this code without breaking anything else. So the first question we can ask here is maybe, we can alter this condition. So I can reform my condition now. I'm going to change this to an else if. So now I'll write this out and then tell you like kind of how it's going to read it. But I want this same behavior, but I'm trying to account for this higher number case. So anything, if number of turns now is on the high end, if we're on the high number end here, if it's greater than or equal to 8, if I sent in turns to be 8 or more, I want to do division now. I want to return, let's say I want to return not subtraction anymore. I want to add those two together still, but I want to divide by 5. And what was our broken one? Oh, this one is not, that one doesn't work, right? I don't think that one worked before. I think I copy pasted that in. Anyways, let me make sure I wrote this correctly. If I pass in 8 turns, we start from student 2, that makes 10. And then I divide 10 by 5, which gives me 2, which is we just did the whole process. But if I have any multiple of 5, I should end back up at that student again, right? So now 8 is working, but I changed the code. So it is a good idea. Let's do this. I'm going to console.log to make this so I don't have to keep commenting and uncommenting. I'm going to say our 0 case is, and I'm going to put the value, whatever that value ends up being, I'm going to put that. I'm basically going to write out a readable sentence for myself. It should be 2. So we'll see what that looks like. I'm going to do it for each one of these. That way I can just run this one time and then eyeball the whole entire. I'm basically writing a very friendly looking test for myself. So 0 case is 2. This is the value we got back, and it should be 2. Good. So I can visually tell that that one worked. I'm going to copy this now, and this way I don't have to keep uncommenting everything. So this is going to be our 1 case, and I'm saying 1 is the argument, pass in 1, and as my comments, my working comments before said, that should be a 3. So if I do this each time, I can skip all these comments that I am doing. So 3, which should be 0. This will make it a lot faster for us to run this code and then eyeball it real quick. So I expected 2. The 7 case is that, and I expect a 4. And if I put in 8 plus student 2 makes 10. So I should get back student 2. So if I put in an 8 for my input, I expect to get back 2. So let me get rid of that. All right, now we can just like see all these output at one time, so we don't have to comment, uncomment all of these again. So I should get all of these lines should print out. And we have to wait for it to run. Looks like it went to sleep maybe. Let me copy, reload. I have like 9 minutes left. And still there. All right. All right, so eyeballing this real quick. 0 case is 2, we got a 2. 1 case, we got a 3 back. It should have been 3. Like these are all lining up. So everything is good so far. Every one of these is good so far. So this division is working out. How high of a number can we put in here? Like, what if I pick a much bigger number now? So I happen to know, just from testing this so many times, if I am able to make this number a multiple of 10, right? Like if the combination of my number of turns and this number 2 student, if I can make that a multiple of 10, it should always end up on student 2. So that means I can actually pick any really high number that I can add 2 to. I can add 2 to, and it will give me a multiple of 10, and I should always end up on student 2 because that number never, we have 5 students and never changes. So I should say a multiple of 5, I'm sorry. But 10s are multiples of 5s anyway, so technically right. But I meant multiple of 5. So let me do that. So what's a high number we can use? Like if I say I can't say 80. I have to actually say 78 because we're going to add 2 on it because student 2. So if I pass in 78 turns, we start from student 2, I should get back a student of 2. So that's my expectations. Just because I've tested this so many times, I kind of know that multiples of 5 are really easy case. Let's run that. We didn't get that. We got a 16. So that's not working. So division works up to a point as well. So why? What happens in this? Maybe we can, 78's broken. Let's pick a smaller number like 25. Oh, not 25, 23. That way it makes 25. Now we get a 5. Sorry, that says 72 still. So it's still broken. We get a 5, but we know that it breaks after, let's see, we can try 18. That would make 20. See if 18 is broken. 18 gives us 4. We know it needs to be 2 because if it's a multiple of 5, it needs to be a 2. So who is breaking? Is it 13? That gives us a 3, so we're almost there. And then what's the next one? So now we're all the way back down to 8 again. So 8, we already tested 8. 8 works. So everything after 8's broken. Did I write this wrong? I didn't write this wrong. All right, so everything after 8's broken. That's fine. We can look at, wait, was it 13 that I tried? It was 13, right? 13 gave us 3. Let's look at 13 real quick. Let's see what happens. We give it 13. 13, we add 2, we get 15. 15 divided by 5 is 3. That makes sense. I mean, that math operation completely makes sense. So that's not what we want. So division isn't a perfect solution for this. Darn. Let's, we have a thing called modulus. Modulus is kind of like a remainder for something. So what would modulus give us? If I said 15% 5, so 15 is our sum of numbers, and then I used 5 students, I get a remainder of 0. But so 0, we want 2, right? 15 is a multiple of 5. We know that multiples of 5 always land on student 2. So if we started from student 2 and modulus gives us the remainder of, modulus would give us the remainder of this, what this division would be. So if it was 15 divided by 5, we get a 3. And modulus gives us the remainder, what's left over from this division operation. It just gives us what's the integer version of what's left over. So if you divide 5 into 15, it goes in perfectly 3 times, so there is no remainder. So that means 15 modulus 5 would equal 0. And this will show you that we might be able to use this 0 in some clever way. So if we perfectly are able to divide into a number, can I just add the original student back to that? Like if my starting point is student 2, and if I perfectly am able to divide into this number, I can just add 2 to my remainder that's left over, and that will give me it should give me a 2, which kind of solves this case, but does it solve the rest of them, like the higher number that I tried? And that's the question. So does division alone wasn't working for us? Is there a way we can try another operation or combine some operations to try it? And that's what it's trying to get you to do, basically, is understand how to use modulus to maybe solve your problem. So 15 modulus 5 is remainder. If I were to divide 5 into 15, I would get a 3. What is left over is our modulo. It's our remainder, which is 0. But if it was a different number, if it didn't perfectly divide, like if I said, let's try a different number. 9. If I divided 9 by 5, it goes into 9 one time, but how many are left over? You would say 5 into 9 is 1. There is 4 left over. So technically, the modulo for this the remainder for this would be 4. Does that help us in any way? Is the question. So if I was to take 7 turns, right? Like if I did 7 plus 2, so that I got 9, and it gave me back 4. What was 7? 7 should be 4. That kind of looks promising too. So if I am able to use modulus in here, right? Maybe there's some way I can use modulus to achieve what I need to instead of division. So now I'm just at this point, I'm just gonna try things. So I kind of want to do this exact thing. Like I got a remainder of 4. Like this one doesn't solve my problem, but this one does potentially. And let's do if it's maybe I'll leave it like this for the moment, and then let me leave that there. I'm going to leave that there for the comments. Let me run it with modulus by itself and see if these come out still the same. So the 2s and the 3s, these are all fine. The 4 is fine. 8 says 0, so this one's wrong. 25 is wrong. So my perfect division cases are still wrong. All right, Patrick, good night. We're probably we're hitting the end of our time. Our perfect division cases are wrong, right? So anytime modulus comes out to be 0, we seem to be behind in one. But does it work for other cases? And that's a question. If I want to do an odd number here, like if I know that if 13 makes 15, which is student 2, if I bring this down to 12, that would make 14, which should technically be the student form. So that should be student 1. So what I want to check a case where it's not a perfect division, right? I kind of want to check that. So my modulus gives me 4. It should technically be 1. So that's not giving me what I want either. And I'm going to put that in here. So 12 plus 2 modulus 5. We get a remainder we get a remainder of, what is that? 2. 2 goes into that, and there's 4 left over. So 2 times 5 is 10, and then to get to 14, we need 4 more from that. So we're basically stuck on this. All right, modulus worked in one scenario, but doesn't work in some other scenarios. And Neil, did you already solve this one? I'm kind of dragging this over time. So I'm just curious if you, because you suggested modulus, I'm curious if you solved it too. Is Neil still here? Yeah, Neil's still here. If not, it's fine. Oh, you already have it? How is your code close to mine? Because I don't want to like bring in your code, and I don't want to bring in your code and then have to like, I don't want to have to explain all of your code. But
I didn't use any conditionals. It was basically a quick modulus statement, or quick mathematical operation, including modulus. It was, it didn't require any conditionals.
Yep, I'm totally going a long way, like the way I think like someone might try to expand it out to. But because I dragged this out so long, we're running short on time. So yeah, send me that, and if it doesn't look too complicated, we can go through it and talk about why it works real quick, and then we can end this.
Do you want me to just drop it in the chat here?
Sure.
Okay. 1 second.
But yeah, I really wanted to stretch out like why the normal approaches, like you would start out with maybe addition and then try out subtraction, and then division was the next one to go to when you're starting to deal with much larger numbers. Division helps like greatly reduce that. Modulus kind of, if you really play around with modulus, you'll see that it kind of has to stick to certain cases. It has a range of numbers that it sticks. It follows a certain behavior when you're working with it. So, all right, he shared his code. Yeah. So basically, if you want to see what it turns out to be exactly. So once you get clever with your, oops, sorry, I think I put this. He was able to solve it, the whole thing, with the one line, right? So technically, all the work we did right here was to build up to the point that like, this is all just us trying to make it work, like doing all these stacked conditions. And if you work with us enough, you'll end up realizing once you start recognizing the patterns of all your math operations, let me get this out of the way. You get to a point where you're like, all right, if I know my number of turns and I get the remainder of my number of turns, so if it's, if I'm doing 12, like 5 goes into 12 2 times, there's 2 left over. So it would be a 2. And if I add 2 to my starting student, I'm just grabbing my remainder and doing addition with it. So I'm pretty sure that gives us 4. If I'm doing this in my head fast, well, in my head right. So let me run this and we'll make sure, because first of all, let me comment this out. I don't have to comment this out, but I'm going to, the moment we run into this return line, it ends the function anyway. So I don't technically have to comment that out, but I'm going to, just so it's obvious what I'm doing. So we get a 2, 3, 3. The 3 cases 5, it should be a 0. Uh-oh. Maybe my logic was wrong. I think I invented this one, so maybe I'm wrong. We can check that. But the ones after it, 2 is right, 4 is right. We got a 5. So it might not be a perfect solution, but it handles a lot of them. It actually handled some of the other ones. It didn't handle this one. Was that? I did pass an 8. Turns. So yeah, so there's actually, there might be an edge case with your code, right? Or maybe I logically worked this out wrong. So let me just double check what 8 is before we continue. So we won't have this, I'm not gonna stretch this out too much longer. Maybe we can leave this and see if anybody can figure it out, and then I can post a solution tomorrow or something. I kind of want y'all to work your brain around this, and maybe you can use what we have. But let's make sure that my logic is correct. I don't want to send you away with this code and then be like, Niels is wrong, or Luke, or who is it, Lucas? Lucas is wrong or something. Yeah, so 8 is the case, and thinking about taking 8 turns from a student of 2, right? So 3, student 4, student 0, student 1, student 2, student 3, student 4, student 0. What did we get? I just lost my train of thought. Did I just do 8? I said it should be 2. If I take 8 turns from student 2, 3, 4, 0, 1, 2, 3, 4, 0. Did I do this wrong? I did this wrong, didn't I? So that should be student 0, but we still got a 5. I know 5 is wrong. Anybody see what I'm doing wrong? I'm doing something wrong here. So we start from 2, we go to student 3, we go to student 4, go to student 0, go to student 1, go to student 2, go to student 3, go to student 4, go to student 0. So my actual logic is wrong here. 0 is what should happen there. So my multiples of 5 thing is wrong. Okay. So I think I maybe made an error. Let me check another case, because so I'm not going insane here. 12. I said it should be 1. We always start from student 2. So 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That should be 4. That's 12 turns. What did I say it land on? Did I say 1? Damn it! I just lost track of what I was thinking. 3, 4, 1, 2. Oh wait, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That should be 4. But I had 1. Okay. Don't listen to me. I think my logic was wrong here. For the ones that I created down here, the bigger numbers, it seems that my logic was wrong for that. So I just want to make sure that the 7 is still correct, right? So if we gave it a 7, now went to 3 and 4 and 0, 1, 2, 3, and 4. That was a 4. So 7 still correct. I don't know where my thinking went wrong right here. I must have counted it wrong, but we're still, so your code, right? Your code isn't perfectly solving this, which is fine, but it solves most of them. It just doesn't solve what looks like, did I update that? 12 cases of 4, let me rerun it. 8. So for some reason we're getting a 5. On 3s, I think I know why. On 3s and on 8, all the rest are okay. So 3, Wait, why is 5? Yeah. All right, so we're over on time. I don't want to keep holding everybody here, and we can work out if anyone wants to try to work out the edge case here that's happening with these numbers, I'm gonna put this in the Slack. So, and I'll leave it like this so you can just run it and then eyeball all of these. Edge case with potato. Which one is it? 3, 3, and 8. Whoops, not 5, 8. Because we're getting zeros, or at least that's what I said it was going to be. That is what it came out to be, right? So 3. Let me make sure this is right. Input of 3 turns. We're getting back a 5 for some reason with that code. We're expecting a 0. 1, 2, 3. That's correct. That one's an easy one to check. So we want to get student 0 back, but we're not getting it. I kind of want to leave this here and see if you can make sense of what we did. And I'm gonna leave my code in place, but I'm gonna put Lucas's code. That's who it was, right? Lucas shared his. I'm gonna put his down here. As a comment. If you want to play with this one to try to solve it, or you can try to modify my mine shortened solution. You use one or the other. All right. And maybe I'll leave this tonight so y'all can try to like wrap your brain around it, modify it, and get these like edge case, fix the code, but rerun it to make sure that you didn't break any of the other cases. All of these cases should have to pass. And then you can experiment with your own, because I'm going way over on time. If I keep going, we're gonna end up at like, we're gonna go for like another 30 minutes of like dissecting this at least. But yeah, I'll share this code. Y'all can have a go at it for practice, and then maybe like tomorrow or when you guys ask for it, maybe we'll spoil it. We'll spoil the solution, like what this little edge case is or how to solve it. And I won't spoil it unless you guys ask me to spoil it. But all right, I'm gonna stop the recording here.